Okay, so friends, now properties of rational numbers. So now we are learning the rational numbers. Okay, so now we'll see the properties of rational numbers. So in the previous session, we have learned that what are the rational numbers, the existence of rational numbers, the need for rational numbers, why they need to exist, like how the natural numbers existed. See, natural numbers is 1, 2, 3, 4, 5, 6. Then because that is not sufficient, then 0 is added in that. Okay. Similarly, negative numbers and positive numbers. Then rational numbers. Okay. So now the properties of rational numbers we will see. So what actually they satisfy the given properties. Okay. Now this is the closure property. Closure property means suppose it's a set. Actually natural numbers is a set, rational numbers is a set. Okay, integers is a set. So now in this closure property means, suppose if I take any two elements, say a b from set rational numbers, then if I add these two, I should get one more number, because if you add two numbers, you'll get another number. So that another number must be a natural number, belongs to the same natural number. Okay, that means if I take any two numbers a b, if I add them a plus b, that is equal to c also must be in this only. Okay, you understood? Okay. Now suppose if this is natural numbers 1, 2, 3, 4, 5, 6, so on. Now this closure property under this addition, you take any two numbers, 3 plus 4 is equal to 7. Again 7 belongs here. Okay, 7 plus 8 is equal to 15. Again belongs to here. Okay, so 3 plus 7, 10 belongs here. Okay, any number you take, this is an infinite set. In the infinite set, any two numbers you add, you will get again the number that belongs to this thing. Similarly, now coming to this rational numbers, now the properties will check. Okay, now addition, if I add in the rational numbers now we are looking at whole numbers. Okay, now first we'll see whole numbers, the properties. In the whole numbers, if I add 0 plus 5, because whole numbers starts with 0, 1, 2, 3, 4, 5, 6, a whole number, I'll get 5. 5 is again in the whole number. 4 plus 7, same. So therefore, if I add a plus b, two numbers from whole number, I'll get some c that again belongs to the whole numbers w, right? That means if this is w is a whole number, 0, 1, 2, 3, so on numbers are there. Take any two numbers, 0 plus 2 is 2 again here only. 0 plus 3 is again in this whole number only. 2 plus 3, 5 again in this. So therefore, the closure property satisfies. That means, if you want to say that if this is the whole number, any number a b if I take from here, if I add a plus b, c must be here. That means c again belongs to whole numbers, right? So therefore, then this whole number satisfies closure property under addition. Okay, under addition it is closure property. Now let us see the next one. Now coming to the subtraction. The subtraction means any two numbers you take and subtract, we should get the same number again from the whole numbers. But see here, if I take this 5 minus 7 is minus 2, but minus 2 does not belongs to the whole numbers. Okay, so therefore whole numbers, because whole number starts from 0, 1, 2, 3, 4, 0 and all positive numbers, whereas here 5 minus 7 minus 2 does not belong. But suppose if I take 7 minus 5, that is 2 belongs. Okay, similarly there will be so many things that belongs, but 5 in any two numbers if I take, okay, 2 plus 3 2 minus 1 1 belongs, okay, but there should be all the numbers should satisfy. There should every two elements belonging to the whole numbers. The subtraction must be again belongs to the whole numbers, whole numbers. So suppose, but 7 minus 5 2 belongs, but 5 minus 1 minus 2 does not belongs. Therefore the closure property, under closure property, subtraction is not closed under whole numbers. Next, multiplication. Next one will be multiplication. So in this multiplication, if again same two numbers if I take and multiply, two numbers if I take and multiply, I must get the same. 0 into 3, 3 again belongs to whole numbers. 3 into 7 21 belongs to. So in general, a and b are any two numbers if I take from the whole numbers, if I multiply, I'll get again a whole number only. So therefore the whole numbers are closed under multiplication. Next, division. Division, what does it mean, division? In this division, okay, in this division, if I divide if I take two numbers and divide them, if I take two numbers, if I take two numbers and divide, I must get a number again belongs to the whole numbers. But if I take 5 and 8, if I take example, 5 by 8 is a fraction, okay, so that does not belong. For example, if I take 2 by 5, 2 by 5 is how much? It is 0.4. So 0.4 does not belongs to the whole numbers, okay. So therefore they are not closed under division, okay, right. Okay, let us see one more time. So what we have seen, only subtraction does not satisfy, remaining all satisfies, okay. So what we have seen here is, in this subtraction, closure property, for this closure property, plus satisfies, division division does not satisfies, multiplication satisfies. So in this closure property, so this subtraction and division will not satisfy, okay. Now next we'll see integers.